Okay, thank you. Good morning, everyone. I appreciate the opportunity to chat about the inspection side of things. I know that we've been doing this for several years now, and it's always good to get feedback. My name is Kevin Jensen. I'm the senior lead robot inspector for the Chesapeake District. I've been doing this for 3, 4 years now, I guess, depending on whether or not you count last year as an actual year with the limited number of events we had. So what we'll go is I'm just going to dive right into this. The whole point of this presentation is to kind of discuss the ups and downs of the inspection process, some of the insights I've seen from several years of working with robots, and then also kind of just some guidelines. So the fun part about this is that the what's new section is going to be very limited. And everything else we'll blaze through. I'm a fairly fast talker, so if anyone has any questions, I don't think I can actually see the chat easily. Yeah, I can't see the chat while I'm presenting, so Don, if you could let me know if there's a question, that'd be good. So one of the things that I always try to instill with all of the inspection teams is this concept that the inspectors are your friends. When we go into a meeting, when we talk with students, when we talk with teams, we're trying to think about it in the context of how do I help them? How do I get them into their place so that they can go to every match, every game? And so within that in mind, I always have 3 priorities. The first priority is safety. No matter what, the situation must be safe. The second is everything has to be compliant. We need to make sure that everyone's following the rules. And then finally, everything has to be fun. Ultimately, our goal here is to inspire the next generation of scientists and engineers and technologists. And we don't do that if we put them into a position where they aren't having a positive experience. And because robot inspectors are one of the most forward-facing set of volunteers that a student will see, that is a particularly important rule. And so in that context, we have the 2 goals: every team, every match, and then everyone try to help improve the robots as much as possible. And the second part of that goal is one of the reasons why I'm here, because I always like to get that insight. So what's new? I have no idea. Since this is such a weird year, they haven't really discussed anything with us. Since there aren't any matches, we're kind of at a standstill. So this is kind of like more of a feeling of how things have been and what you can prepare for following years. For district events, which are the ones that most teams are familiar with, we have that 3-day system. Day 1 is from 6 to 10. The pit's open. You can be inspected immediately, and we encourage everyone to inspect themselves immediately. Day 2, you get your qualification matches starting at 11. Unless there's an otherwise specified rule, you can load in up to the point of opening ceremonies. We've been kind of emphasizing that. My goal is to finish all the inspections as fast as possible. And then during the day, we'll just have walkthroughs and keep an eye on robots and make sure that battery straps are still in place and that there's nothing going on. And then if the team comes, usually most of our inspections are at that point are via re-inspections when the team asks us. And then on day 3, we'll continue to have random re-inspections. And then playoffs, what we'll do is we weigh every robot. For the championship event, the flow is very similar with the exception that it's an extra day. Pits open at 5, you can inspect immediately. The load-in events are always at opening ceremonies. We have our practice matches from 10 to 12:30, and then we have basically the same process through the others. The key points, things that I like to emphasize as much as possible. First, please start the inspection early. If one of the nice things about the no bag rule is that we can actually, we don't have to necessarily wait until the event to inspect the robot. I would love to have I'd love to have teams reach out and see if we can't get some on-site inspections or One of the things I'm hoping to advocate for next year is more of the inspection days like we had last, I think it was 2 years ago. That was an amazing experience for everyone involved. We had everyone there. We were able to really work out some problems with the teams. It gave me the opportunity to train my inspectors. So the hope is that we'll be able to continue to do that. In fact, Chesapeake District was one of the most, it's kind of at the forefront of that type of inspection. When they opened early inspections, I think it was 2 years ago, we had the most teams pre-inspected by far. And to be clear, pre-inspection just means we look at it. We don't, there's nothing about the early inspection process that allowed us to speed up anything during the actual event. It just means that if there's a problem with your robot's frame, if there's a problem with any other type of compliance, we can look at that very early. So reach out. My email was at the beginning of the presentation. I will make sure that Don gets this slide, and and just do what you can. The inspectors, they're there to help. They're there to guide teams through the inspection process. Ideally, I want to speak primarily to students. I actually try to tell the adults to leave and go get a drink or something and come back later. To get started, it's very simple. Just go to the inspection station, send a representative, and ask to be inspected. You'll be added to the list. Please don't bring your robot to start off with, because our inspection stations are always in a very limited space, and it's hard to pull that off. One of the things that kind of was emphasized last year was the concept of what is your robot and what is cheesecaking. The idea is that your robot and its major mechanisms must be built by that team. Major mechanism being a group of components or mechanisms that solve a game challenge. It moves the robot, it controls a game piece, it manipulates a field element, or performs some type of scoreable task. The reason that this rule is there is because we don't want to be in a situation where teams feel like they have to take a component that another team builds and put it on their robot for the purpose of improving their play, the concept of cheesecaking. Now, to be clear, we're not in this, this particular rule has caused a lot of consternation in the past. And my philosophy is that it's not there to prevent teams from helping each other. If a team needs help and like it happens every year, they get swarmed by all the other teams that are there to help and do all that really good work that I love to see. And the end result is there's a mechanism that comes about. I'm not going to sit there and demand who worked on it, who built it, what happened. What I don't want to see is, I just don't want to be in a situation where I see a team have an array of like of literal mechanisms, scoring mechanisms, and they come over and they say, okay, you're on a reliance, bolt this to your robot. That's what I1 is intended to prevent. There's some examples of major mechanisms there. Things that are not major mechanisms: gearbox assemblies, COTS items, any subset of a major mechanisms. And you know, if you try to exploit a loophole, well, that's a violation of I1 too. If you give someone a box of parts and say, here, put this together, and it forms a major mechanism, then that's not going to work. But realistically, this is the kind of thing where it's going to be mostly self-reported or seen by other teams. And as long as you maintain the spirit of the event and you aren't providing complete assemblies to other teams, and are instead looking at the concept of, I want to help the team, I'm going to help repair the robot, I'm going to help work together, that's fine. I3, bring it all to inspection. Sometimes, not often, but sometimes we see teams that have different configurations on their robot. They have a series of mechanisms. Sometimes they can perform task A, sometimes they can perform task B. And so what I3 basically says is, any robot up to 150 pounds of robot can be inspected at once. Any combination of mechanisms. And as long as that 150 pounds of robot mechanisms is inspected, they can be used together. Now, any configuration that you use has to weigh less than 120 pounds. And if I know that configuration A and B together weigh 120, but configuration B and C weigh 135, and I see you with configuration B and C, then that's going to be a violation and probably very bad for your team, because you'll been playing with a robot that wasn't accepted or hasn't passed inspection. But the goal here is to try to minimize the amount of hassle that we have going on. And just as I said, if you have it, if it's been inspected within that 150 pounds of inspected items, then you can add it, remove it, reconfigure. You're fine. If you modify your robot after your most recent pass inspected, please call us over to reinspect. That is sometimes when we say modify, we say like significant changes to the robot, physical changes, like if you know, drilling holes, changing mechanisms for new ones. If you're doing things like using fasteners, markings, or if you're just doing an identical replacement, then that's not a reinspection. That's a repair. And then also, please only bring one robot to the event. If we see more than one, then we have to take one. So the initial inspection process. First thing we do, so you bring the robot over, you remove the battery and the bumpers, you take all your mechanisms, and you weigh it. We weigh the bumpers individually, add all the mounting hardware. Please don't step on the scale. The scales are older than most of our students at this point. For sizing, usually it's without bumpers. We'll just see whatever the method is, we deal with it. We try to have a box or something available so we can just kind of visually check it and move on quick. After the initial inspection, we move on to the pit. We try to minimize how many representatives are in the pit. Ideally, we'll have about 2 students. We want to make sure the robot's in a safe condition, so we turn off the robot, we minimize all the pressure. We just make it into a low energy state. Once you have proven that the robot is safe, then the inspection can begin. Bumpers are always fun. I don't know what it is about teams that can make these amazing robots with advanced programming that can't do plywood and pool noodles, but it always seems to be a challenge for some teams. But it's part of the robot. I don't think FIRST is going to go away from I don't think FIRST is going to go near any events that don't require bumpers anymore. So just, they're here to stay. They're never going to go. The construction's very simple: 3/4 inch plywood, pool noodles, that nice durable fabric cover, and then a proper display of the team number. I find a lot of times that with a team that has a good robot, if they felt kind of rushed, the bumpers are usually the last thing to think about. And often that leads to something that's not necessarily the most securely fastened and easy to remove. For me, securely fastened means that when I move the bumper, the robot moves with it, that there's no play. Also, every year there's been rules about gaps in the corners. You're not being allowed to have them, and a minimum 1/4 inch spacing or a maximum 1/4 inch backing between the robot and the frame perimeter. So if you can keep an eye on those things and check it aggressively, that'll be best for you, because bumpers are often very hard to fix due to the way they interface with the frame. They're not an afterthought. They're mandatory. Your bumper can fail your robot just as easily as the rest of you. Try to avoid bumper covers or convertible bumpers. Very rarely do I see them done well. And I know that FIRST has done a pretty good job of changing the rules to make it so that, you know, if a thread from a bumper is touching the floor, it doesn't disqualify you anymore. But just the bumper system as it is right now with the 2 swappable configurations is pretty good, and the more you can maintain that, the better. Next up, we have mechanical inspection. I'm a mechanical engineer, so this is my favorite part. The bill of materials. Please have one ready. Just honestly, my favorite thing to do is just to say, have it on Google Drive, so that when and share it with all of your students, so that when I say, hey, where's your bill of materials, no one's panicking. You can just go, someone looks it up on the phone, they show it to me. I verify that it has the cost of materials. I verify that it has the proper allocation of everything, and then we move on. These robots are pretty complex, and I'm just not in a position where I can like perfectly analyze your bill of materials, but it does need to be there. For me, the big things I look at are the hazards. So the first one being sharp edges and protrusions. I look at hazards to personnel or fields. I look at leading edges. I look at points. I look at undersides. My personal favorite are the improperly cut tie wraps that always like to demand the sacrifice of blood. And I'm also a really big fan of looking at areas of concern. Any part that interacts with the game piece. If there's a part of the robot that can puncture or is designed to interface with the field, I'm going to be pretty careful about that. Anything near the breaker is of concern, because that's the thing that theoretically someone is going to be reaching towards in a panic. And if it's in an unsafe location, then we'll have to fix that. And then obviously near battery connections, because we want to make sure that there's no electrical hazards. Another area of concern that we've had recently is the underside of the robot. On all of my inspections, I will make sure that the robot is lifted up so that I can look at the underside. I don't want to see any bolts sticking out. I don't want to see anything that's going to catch a field element. There's a 120-pound robot with a 1/4-inch bolt sticking out of the base. If that catches something like a cable line or something and it rips it open, the field could go down for a sizable period of time. Energy storage is critical. There's one approved battery or one approved style of battery. That's the only one you can have. If you're going to do any type of elastic energy, spring, surgical tubing, bungee cords, make sure they're properly contained. Your storage tanks need to be safe, and everything has to be safe to be around. For batteries, I love to use either like a 2-inch cinch strap or some type of secure battery tray. My philosophy is, if I can take the robot and turn it upside down and shake it and the battery doesn't come out, then you're good. No one wants to see a battery on the field. Please be careful about protruding bolts or other items that can damage the battery. A couple of years ago, we had a team that had a battery case with 2 bolt heads that were in the battery region. And what happened is, when they installed the battery, the battery itself was actually resting on these 2 bolt heads. They were rounded, but it created a bit of a lever. And as a result, whenever the robot dropped, it actually started cracking the battery. And by the end of the match, all 5 of their batteries were leaking, which was a record for me. I went from having never dealt with a battery leak to having 5 in a single match or a single event, and that was great. If you happen to use any capacitors, please avoid having them be charged after the robot is shut down. Pneumatic storage. I am a huge advocate for properly and rigidly securing pneumatic storage tanks. I don't like seeing them flop around. Please avoid using cable ties or tape. You can't use tape because it's illegal in pneumatic components, because that's the rules. Cable ties have a tendency to stretch. I'm a much bigger fan of seeing things like brackets or mechanical, like physical restraints, as opposed to something that can stretch. Please don't use things like hose clamps that'll cut into the storage device. If you're using a lot of air, you don't have to use a clippered tank. One of my favorite things is to look at a website like lowriderdepot.com. I just found this place a few years ago, and they have these aluminum tanks that they use for things like the pneumatics on a car, and they actually hold more air for the weight than a equivalent clipper tank, because they're aluminum, they're huge. They're not huge, they're various sizes, but they're a lot more efficient, and they have these nice physical brackets, and they have multiple mounting ways. So if you're going to use a pneumatic system, consider thinking outside of the clipper tank and looking at seeing what other options are available. Some mechanical recommendations: please clip your cable ties as short as you can. A few years ago, every now and then I have a team that thinks it looks really awesome to have their cable ties cut at a 45-degree angle, and it bleeds. It makes me bleed. Just have your students run their hands over every part of the robot, and anything that feels sharp, just file it down. The battery, please make sure it's secure but easy to remove. Constrain in every direction, minimize movement, just don't have any protrusions or the potential sources of damage. And please secure your pneumatic storage. Ideally a cot solution. Clamping is better than cable ties. If the storage tank can move, it'll undergo scrutiny. Ballast. We haven't had a lot of ballast recently, but if you need to have ballast, it has to be in compliance. That means it can't be an additional battery and it can't be a threat to the field. So no uncoated dive weights. That's actually more of a thing in Florida than around here. No exposed lead. And if you're going to have a container of loose, don't try to avoid things like containers of loose fasteners or ballast. I forgot which event it was, but someone had a glass ball full of lead shot, a glass beaker full of lead shot at one event, and that was a no. If you have ballast, it's got to be secured to the robot. Electrical inspection. If your robot looks like this picture, then you're good to go. If you have that level of organization, then that pretty much tells us that you should be fine. Breaker visibility is extremely important. We have had robots escape the field. Imagine you're a stranger with seconds to disable the robot. Can you find the breaker? Can you disable it? Ideally, there should be a nice sign that points to it. It shouldn't be hidden. Just design for access and try to make it so that if a stranger has to deal with it. At the same time, consider the potential for what other robots and the game pieces can do to disable your breaker. If this is a game where the balls fly over the place and they land can land on your robot, then a breaker prominently located at the top that could be turned off may not be the best thing in the world, or you could shield it somehow. The robot radio, just get it programmed immediately so that that's not an issue. Try to mount the radio high and away from metal. Please don't clamp the radio, for example, with cable ties. Depending on the radio, there may be a very thin margin between the grounded plate that forms the antenna region and the board itself. And if you compress it too much, you can cause a short. We've had a lot of success with adhesive hook and loop tape. If you do have to use cable ties, and I'm not saying you can't, just don't encourage your kids to like clamp it down mercilessly. Try to make sure that it has at least a little bit of give. Previously, there's been issues with radio power. You can use both a barrel adapter and power over Ethernet. I highly recommend power over Ethernet. And then the power distribution panel. Please make it visible for inspection, and please make it accessible, not just for myself, but also for your team. If the power distribution panel is easy to see and it's easy to access, then it's easy to repair and it's easy to diagnose. On the other hand, if the power distribution panel is located in the belly of the robot behind 17 mechanisms and requires an inordinate amount of time for us to access, then that also means that it's going to take you that much time to get in there if a wire gets loose. Electrical inspection with custom circuits. Any component of the robot other than the listed ones is considered a custom circuit. Any active electrical item that is not an actuator or core control system item, they can't produce more than 24 volts. They can't directly alter power pathways. So for example, you can't put a custom circuit in between the motor and a wheel, or in between the power controller and the motor. You can monitor voltage or current, and you can't directly control motor controllers or relays. It can be connected to the CAN bus, but it can't interfere with alter or block communications among the control system itself. If you have a remote camera that broadcasts a signal that's Wi-Fi capable, it has to be pre-approved by FIRST. It's better just to not have that happen. Electrical recommendations. The best thing you can do is have clean, well-labeled wiring. Makes it easy to inspection, makes it easy to troubleshoot. I like using the Anderson power pole connectors. They're pretty reliable. They have nice little clips. They're easy to pull apart. I recommend using low gauge wire. Just because the system says you can use 12 gauge wire doesn't mean you have to. I like using 10. McMaster cars sell something called Easy ID low voltage cable. It is a red and a black wire already bonded to each other. If you're going to do battery wire, there's no reason to just use 6 gauge. Maybe go 4. There's an ultra flexible battery wire also from McMaster, which works really well. During your own self-inspection, look at every single connection you have and pull it just to make sure that nothing is loose. I like using perforated plastic sheeting for electrical mounting. McMaster car sells high strength PVC plastic perforated sheets. That's sheeting that's about 1/8 of an inch thick that has a 1/4 inch hole every inch or so, or 1/2 inch. So it's easy to mount components on it and adjust as needed. And if you've got 50 bucks lying around, consider getting a hydraulic crimper. It will absolutely bond the daylights out of your components and makes it a lot harder for them to pull out. Regarding electrical recommendations, please avoid making any assumptions when it comes to motor, solenoids, or custom circuits. Use Q&A. Feel free to email me. Pre-inspections are great. A good example is the automotive motors, although I'm not sure how much that's an issue nowadays, but every now and then I run into someone who says they have an automotive motor. And the bottom line is I will require evidence that the motor is actually for automotive use. It can't just be a motor that is also possibly used for automotive use. It has to be a motor that is actually used for cars. Just try not to clamp your radio. Again, I like using Velcro. And with the circuit breaker, again, think about what would happen in an emergency situation. How quickly can a stranger turn your robot off? Pneumatics. Everyone loves pneumatics. The minimum components of the pneumatic system are a stored working pressure gauge, a stored pressure gauge, a working pressure gauge, a 125 psi pressure relief valve, a pressure switch, that vent plug valve, and a pressure relieving regulator. Please do not modify your pneumatics. You can remove mounting pins from the cylinders of a pneumatic cylinder. You can modify the wiring connected to the control system by adding like a connector to it. Please don't paint or tape over components. Compressor. Any type of compressor is allowed if it meets the specs. Just show me the documentation. The kit of parts compressor is typically undersized. It's only 0.88 CFM versus a limit of 1.1. Note that if you have a lot of air in your system, you can cause a lot of heating. And I think it was the Andy Mark 1.1 CFM compressor. I was doing an event 3 years ago where the compressor was working so hard that it melted the plastic tubing that it was connected to. It actually caused a little hole that caused a pressure release. You can only have one compressor. It can be off board, but it must still be controlled by the robot, and the minimal pneumatic system must still be on the robot. Pneumatic solenoid valves. Non-kit of parts valves are restricted to a 1/8 inch NPT port diameter, and you need to provide documentation. If a solenoid valve is rated below 125, you have to have an additional pressure relief valve on the working side that is set to the pressure lower than the valve rating. Easiest way to solve that is to simply use solenoid valves that are rated at 125 psi or higher. You can only have one solenoid per pneumatic actuator, and they're controlled by the modules. I highly recommend before inspection performing your pneumatics check. Check that the high pressure shows less than 120 psi. Check that the working pressure shows less than 60 psi. Make sure the compressor stops at 120 psi left. Verify that the pressure relief valve works. Short the leads of the switch. Make sure that the pressure relief valve relieves at more than 125 psi. I highly recommend using a static pressure relief valve like the McMaster car model shown there. If you use that, then you don't have to worry about setting it. You just put it into the system and it runs. Try to treat your pneumatics like an electrical system. Cleanly lay it out and label your tubing. The easier it is for me to inspect, the easier it is for you to troubleshoot, and try to simplify as much as possible. It was the picture I showed previously, but that aluminum tank was the equivalent of 6 Clippards. Try to make sure that your gauges, regulators, dump valve, relief valve, and switch are all easily accessible. Gauges in particular, because during events I frequently check them just to make sure that your working pressure is less than 60 psi. We are continuing to find these white Clippard tanks. There's fewer and fewer of them, but if you have a white Clippard tank with a threaded end, if someone gives you a white Clippard tank with a threaded end, throw it in recycle it. It is not allowed for this event, because if you are overly aggressive in tightening the threaded end with a fitting, it will crack and could explode. Follow-on inspections. You've passed inspections, you're playing games, what happens then? Well, if you make a change to your robot, have an inspector recertify it, with the exception of fasteners, changing your code, doing swaps, or any type of modification with previously approved in subsets. If you're not sure about something, just ask us. We're friendly. We like talking to people, and usually by halfway through the event, we're just kind of hanging out. Finally, disputes. This is important, especially for the mentors. There's always, no system is perfect. There will always be disagreements. If you disagree with the ruling of an inspector, please contact the LRI. Robot inspectors are responsible for inspecting robots. LRIs are responsible for customer service. Every single LRI is trained in how to communicate with you, the customer, how it is to address any issues that may come about. If you feel like there is a problem between you and your inspector, don't even, just go to the LRI. There's no reason to get involved with the inspector themselves. If you have an issue with the LRI, you are absolutely welcome to escalate the dispute to me. Just say, hey, this isn't working. Could you please escalate this to the senior robot inspector? And the LRI will contact me directly. And then I will evaluate the dispute. And then after that, if you don't like my answer, you are more than welcome to request that I escalate to Al Serkowitz, the chief robot inspector. I will reach out to Al. I'll get a final ruling. Al is managing the robot events across the entire world, so it's not likely to be fast. And if you don't like what Al says, then too bad, because that's where it ends. Design recommendations. These are just some things that I have found through several years of working with these robots. First of all, do not assume that the field is perfectly engineered. It is not. Ropes broke. So for example, in 2016, everybody's rope broke because of how it was interfacing with the field. There were scratches and stuff. Field elements will get damaged and bent. And even if it's the field fault, it's still your problem. A simple robot that works perfectly is better than a complicated robot that can't be trusted. If all your robot does is defend really well and manipulate one part of the field in a very reliable fashion such that the teams don't even have to think about that anymore, that's better than a robot that will maybe sort of work on, can kind of do a lot of things, but none of them perfectly. The less you have to have the evaluating teams think when scouting, and the less that you have to worry about your robot when playing, the better. And then finally, design your robot as if everyone is out to destroy you, because they are. Emphasize ruggedness and survivability, and design your robot for reliability and repair. Like it or not, first is a competition. It is a element, there is a competitive element to it, and there is a interaction between teams. And so your robot will be abused. It will run into other teams. It will run into field elements. There may be accidents. The more you make your robot rugged and reliable and able to handle that environment, the better. And then finally, there's the FRC blog for any official changes, which I'm sure we're all familiar with since this has been such a weird year. And with that, if there are any questions, I'll be more than happy to answer them. That is my email address, and I'll make sure that Don gets my this presentation.